Okay, chapter 2, we're going to start off by talking about algebraic expressions. An algebraic expression is an expression that has a variable in it, what's a variable? A letter that's representing a number. So for example, on number 1, we're going to write a expression that means the sum of a number and 7. So sum means we're adding, right? So I'm just going to use x, some number, plus 7. This represents the sum of some number and 7. Number 2, the difference of a number and 10. What does difference mean? Difference suggests or means subtraction. So the difference between some number and 10. Number 3, the product of a number and 9. Product means we're multiplying. So kind of the best algebraic way is just to write 9x. If you really wanted to write 9 times x, that would be okay as well. Okay, number 4 usually trips people up. So see if you can write an expression that means twice a number. What do you think? It's 2x, right? Not x squared. That means the number times a number, or times itself. Right? We want it times 2 because we want it twice. Number 5, how would you write an expression that means the number of days in W weeks? Okay, and if you're struggling with it being a variable, think of it as a number. How many days are in 2 weeks? 2 times 7. How many days are in 5 weeks? 5 times 7. So how many days are in W weeks? W times 7. Right? 7 days times the number of weeks. Okay, what about the number of hours in D days? Well, there's 24 hours in one day, so it's 24 hours times the number of days. So the next part is we're going to evaluate, and it says to evaluate an expression for a given value, plug the value in, and work the expression all the way out. Everyone wants to say that this is called solving. It's not. You only solve when it's like x equals this. Okay, this is evaluating, so we're going to plug in our variable. Okay, so it's telling me, hey, x is equal to 11. So I'm going to put, instead of an x, an 11. 11 plus 10 is 21. On number 8, it's telling me that y is 9. So 15 minus 9 is 6. On number 9, it's telling me that c is equal to 12. So 3 times 12 is 36. And then on number 10, okay, everywhere I see an n, I'm going to put a 7. So 2 times 7 plus 5 minus 7. So we're going to use PEMDAS. 2 times 7 is 14. 14 plus 5 is 19. And 19 minus 7 is 12. Okay, we're using PEMDAS every single time. So let's come over here, or flip your page over, and we'll talk about the next few. Okay, so on this one, we're doing 3x minus 4 for x is 6. So everywhere I see an x, I'm going to put a 6. So 3 times 6 minus 4. That's 18 minus 4 is 14. Let's do 14 together. So 6 times 8 plus y, well, it's telling me y is 4, and then n, so like times 2. So we're doing parentheses first because of PEMDAS. So 6 times 12 times 2. Well, 6 times 12 is 72, and 72 times 2 is 144. So why don't you pause it, okay? If you're kind of getting it, you're following along, go ahead and pause it, and then do 12, 13, 15, and 16, and then we'll unpause it and check our answers. So on number 12, we're going to do 10 divided by 5 plus 3 times 5. right? Because everywhere I saw a Z, I went ahead and put a 5. So 10 divided by 5 is 2, and then 3 times 5 is 15. And then 2 plus 15 is 17. And then on number 15, I have 3 different variables to plug in. So I have 4 plus n times x. So PEMDAS, multiplication comes first. 6 times 2 is 12. 4 plus 12 is 16. And then down here, number 13, 6 times n plus 8. So 6 times 2 plus 8. Inside my parentheses, 2 plus 8 is 10, and 6 times 10 would be 60. And then the very last one, I feel like I'm talking a million miles a minute, so sorry. Okay, 4 plus 2 times x is 2, plus 14 divided by y, which is 7. So 4 plus 4 plus 14 divided by 7 is 2. 4 plus 4 is 8. 8 plus 2 is 10.